Once we have a subject to study, in an ideal universe, we'd be able to describe every single possibility of that thing, get all of the data we could possibly want from every single option, and then make some measurements on that, draw some conclusions from that, and make very broad and sure statements. Where what we'd be getting there are parameters, because we call a parameter a measure on a population being all of the things that we are trying to look at, all the things that we are trying to describe all at once. But the thing is, it's incredibly difficult to describe all of the things all of the time, every time. In many cases, it's somewhere between difficult and, in fact, impossible to do so meaningfully. If you want to talk about human beings, for example, and the entire population of the world, get a measurement that is accurately characterizing every single person, you'd have to be aware of the fact that at every single second, there are many people being born and many people who are dying. And even if you could collect all of them in one instant, it would change immediately by the next instant. So you'd never actually have a hope of getting all of them and getting that perfect parametric relationship, perfect parametric representation of the entire population of the world. Usually when we're looking at these things, for that reason, we talk about samples, where a sample is just a subset of the population. In particular, it's a subset of the population that we want to represent in some sense the entire population behavior. We'll talk about that a little bit more later, but the point there is to understand that outside of some weird, small, isolated cases, populations are unwieldy to be as broad as possible. You can't really reasonably be expected to get everything, so you take some of it. And when you take some of it and make a measurement on that, you get what is called a statistic. So, we could say that this class is a class on the study of samples. And the difference between a sample and a population can itself, especially in the context of this class, be a little bit subtle. Usually when you're talking about whatever research you might want to do, you have a sense of what it is you're trying to talk about and a sense of the fact that you're not going to get all of the things. We're talking about statistics and samples, but for the problems you're going to see here, it's important to understand that the difference there is largely a matter of the context in which something is presented. For example, I could want to study all the people in the state of Florida. And if I want to study all the people in the state of Florida, that would be difficult, less difficult than everyone on Earth, but still, I'd have similar problems. The millions of people here are more than one person would be able to manage, forgetting the issues of birth and death, so I probably wouldn't study all of them. I'd study, say, the people in Lee County. But then maybe I might not be interested in the people in Alachua or Polk County or Miami-Dade or anywhere else. I might only want to know about people in Lee. So then, instead of having my population be Florida, I could make it Lee County. And then instead of having Lee be the sample, I could make FGCU the sample. I could focus down a little bit further. And then from there, instead of talking about FGCU as a sample, I could just look at the people in my classes. Make that the population, in which case this class could be a sample because I have multiple classes and you all are a group within them. And that's a good group, different story, but that would be one thing. Or I could be even more specific. I might say that out of all of the people in Florida, all the people in Lee County, all the people at FGCU, all the people in my classes, I'm the only one that's particularly interesting. I know that you guys think I'm particularly interesting because you're still watching my videos after 3 months of them. Point is, the population there wouldn't have to be very many things, it'd just be me. I wouldn't need to worry about a sample at that point because I can study myself to my heart's content, although I don't really want to a lot of times. But that's a subject for more of a philosophy class than what we're doing here with stats. The point is that when we're looking at the difference between populations and samples, you have to be paying attention to the context. If something is placed in a larger group, then you're probably looking at a sample, whereas if something is just talked about in its own terms and nothing else, you're likely looking at a population. Anyway, let's get a couple of examples here so we can better understand the type of distinction we're looking at here. In a recent survey, 834 employees in the United States were asked if they thought their jobs were highly stressful.
Come outside! Come outside!
You're coming close to me! You're coming close to me!
Back up!
Of the respondents, 517 said yes. Identified the population in the sample. Describe the data sets. So, for this, what we are looking at is some representation of the people in the United States who are currently employed. So our population here, which I'm going to abbreviate POP, is going to be the employed American citizens. Pretty straightforward. It's the larger context in which the people we are looking at happen to be. Obviously, there are more than 814 people with jobs in America, otherwise our economy would be in really bad shape. But that's meant to represent everybody in there. So, if you then want to talk about what the sample would be, the sample is, in this case, the 814 respondents, the people who were on the survey. And to be clear, of our data set, that, data, is the responses. In this case, 517 yeses and 317 no's. It's just what came back. The data is what we were looking at, it's the answers. Sometimes data is numbers, and that's mostly what we're going to focus on here. That's what we call quantitative data. And then sometimes these things are just labels, yes or no, black or white, green eyes or blue eyes. Those are what we call qualitative data, but don't worry too much about that. That's notation that's more relevant to a more developed statistics class. Point is here, the population is all the things you want to know about. The sample is the group of things that we are able to access. I don't know why I blanked on the word I want to use there, but that's close enough. And the data that we have is the responses we get from them. So, let's take one more example here to look at a slightly different sort of idea in terms of the difference between parameters and statistics as well. In a study on the entering freshman class at a university, they were found to have an average SAT math score of 514. Is this measure a parameter or a statistic? So, what we should pay close attention to here is the context. We're not talking about all of the students at the local university. We're not talking about all of the freshmen at all universities. We're not talking about all of the high school students who have graduated having taken the SAT. We're just talking about that group there, the freshman class at the one university. Which means that because we are only talking about that one group, because we only care about those freshmen, what we have there is going to end up being a parameter. Because, even though it's kind of an odd population to discuss, we are specifically only looking at that group of freshmen at that university. And in particular, we are looking at the average, which is this thing that we're going to talk about a bit more in section 12.2. But before we get there, I want to take a little bit of time here to talk about what it might mean for data to actually do what it's meant to do. That is, I want to take a little bit of time here to discuss what it means for a sample to be representative.